Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is Design for Testability from Unit 5 ASIC Design and Testing. On completion, the students will be able to explain the different types of fault modeling and also understand the need for controllability and observability in VLSI design and testing. Fault models. In order to evaluate the effectiveness of a test approach and the concept of good or bad circuit, we must relate these faults to the circuit model or derive a fault model, which is a model for how the fault occurs in a design and how they are affecting a design, that is their impact on the circuit. Fault models are representations of potential defects that can occur in a chip or in a design. Common fault models are as follows. Stuck-at faults. Here a logic stuck-at 1 means when the line is applied at logic 0, it produces a logic error. That is 0 becomes 1 and vice versa. These faults assume that a particular node in the circuit is stuck at either 0 or 1. Transition delay faults. These faults model timing related issues where a signal changes too slowly or too fast. Path delay faults. These faults model delays along specific paths in the circuit. Bridge faults. These faults represent a short circuit between two nets or nodes. Cell-aware faults. These are specific to certain types of cells and are critical for nanometer scale technologies. Stuck-at fault. A stuck-at fault is a fault model used to identify and fix defects in digital circuits. It is a most common fault model. It is a fundamental and widely used one in digital circuit design and testing. In a stuck-at fault, a signal or a pin in a digital circuit is assumed to be stuck at either logic 0 or logic 1 instead of transitioning as it has to do. This can indicate a defect or malfunction in the circuit. The stuck-at faults may be either a stuck-at 0 or stuck-at 1. Stuck-at 0 means the net is permanently stuck at logic 0, whereas stuck-at 1 it is permanently stuck at logic 1. For example, in the given diagram we have an AND gate whose output is stuck at 0. So whatever may be the input given to the AND gate, it will be producing a 0 output only. So in this case we are giving two high inputs and it has to produce a high output, but as it is stuck at 0, the output is 0 only, and this will create an error in the entire circuit output. Transition delay faults. A transition delay fault is a type of delay fault that occurs when a signal's transition is slowed down in a digital design. So these are caused by the finite rise and fall times of the signals in the gate as well as the propagation delay between the gates present in the circuit. So there are two types of transition delay faults, which are slow to rise as well as slow to fall. Test coding. Test coding involves writing test patterns to test the functionality and detect faults in a chip. Various methods and languages can be used for test coding, such as automatic test pattern generation as well as built-in self-test. In automatic test pattern generation, test tools are automatically generating test patterns based on the fault models, and built-in self-test structures are embedded within the chip to facilitate self-testing. Scan chains. These enable efficient testing by serially scanning in test data and capturing results. Test benches. Test benches are used for simulation-based verification where test stimuli are applied to the design and responses are analyzed. High-level test languages. Some specialized languages and tools are used for high-level test descriptions, which can be automatically converted to lower-level test patterns. Design for testability. The keys to design circuits that are testable are controllability and observability. Controllability is the ability to either set and reset every node internal to the circuit. Observability is the ability to observe either directly or indirectly the state of any node in the circuit. Good observability and controllability reduce the cost of manufacturing as well as testing because they allow high fault coverage with relatively few test vectors. Three types of testing available are ad hoc testing, scan-based approaches as well as built-in self-test. Ad hoc testing. Ad hoc test techniques are collections of ideas aimed at reducing the combinational explosion of testing. It is useful for smaller designs where scan-based approaches as well as built-in self-test are not available. A complete scan-based testing methodology is recommended for all digital circuits. Common techniques for ad hoc testing are partitioning large sequential circuits, adding test points, adding multiplexers, as well as providing for easy state reset. A technique classified in this category is the use of bus in a bus-oriented system for test purposes. Each register has been made loadable from the bus and capable of being driven onto the bus. The internal logic values that exist on a data bus are enabled onto the bus for testing purposes. The tester can access all the subsystems which are connected by the bus. The tester can disconnect any functional unit from the bus by setting its output into the high impedance state. The test pattern for each subsystem can be applied separately. Multiplexers can be used to provide alternative signal paths during testing. In CMOS, transmission gate multiplexers provide low area as well as reduced delay overhead. Any design should always have a method of resetting the internal state of the chip within a single cycle or at most a few cycles. Apart from making testing easier, this also makes simulation faster as a few cycles are only required for initializing the chip. Scan-based approaches. The scan design strategy for testing provides observability and controllability at each register. In this method, the registers operate in one of the two modes, scan mode as well as normal mode. In normal mode, registers behave as expected, whereas in scan mode, registers are connected to form a giant shift register called a scan chain spanning the whole chip. By applying n clock pulses in scan mode, all n bits of the state in the system can be shifted out and new n bits of the state can be shifted in. Therefore, scan mode gives easy observability and controllability of every register in the system. Modern scan is based on the use of scan registers where the scan register is a D flip-flop preceded by a multiplexer. Built-in self-test. Self-test and built-in test techniques allows the circuit to perform operations upon themselves that prove correct operation. These techniques add area to the chip for the test logic but reduce the test time required and thus can lower the overall system cost. One method of testing a module is to use signature analysis or cyclic redundancy checking. Quiz questions on design for testability. Explain the different types of fault modeling. What do you mean by design for testability? Name the three types of testing methods. Thank you.